Hey guys, Mason Coon here. Welcome back to another episode of Spectroscopy.
Today we'll be looking at a molecule of 7-chloro, 4-hydroxy, 3-quinoline carboxylic acid. First thing we'll look at is the mass spec. Farthest over to the right here will be labeled as M+, which is the mass of the molecular ion right here, 223. Base peak is where the relative intensity goes all the way up to 100. Label that the base peak. Now we'll be looking for fragments of the molecule that will be passing into, or there will be between the distance of the peaks here. The first one here goes to 206. There's 17 in between. That represents nothing. The next one is at 179. It's actually 44 and can represent two different things, which I'll draw up here. So essentially what this says is, since there's a fragment here at 44, either of these fragments could be seen in the molecule. This one down here goes to 53, which doesn't mean anything. So that could wrap it up for the mass spec. And now we move to the degrees of unsaturation formula, which is 2C plus 2 plus N minus H minus X all over 2. And this will be equal to the number of rings plus the number of pi bonds. And pi bonds is another term for double bonds. C stands for carbon, N stands for nitrogen, H stands for hydrogen, X stands for halogen. So now if we move to the formula, do it ourselves, we see that the formula has 10 carbon atoms in it. We add the 2 from the formula, add 1 nitrogen, which is in our formula, subtract the amount of hydrogens, which is 6, and then there is 1 chlorine atom, so that'll be 1. If we divide this by 2, it ends up being 8. So we'll be looking for possibly 2 rings, and essentially it would be 6 double bonds in the atom, or in the molecule. So now we move into the IR spectroscopy. I've pre-labeled this for all the zones in the fingerprint region. So if we look into zone 1, we can see there's not a whole lot of activity. It starts to fade into zone 2. So zone 1 is empty. I'll put nothing here. Zone 2, we can see it kind of looks like a big beard on Santa Claus. That usually signifies a carboxylic acid, so I'm going to write that one down. And then also aromatics can come from this region, so I'm going to write that down as well. If we look at zone 3 here, we can also see that there's nothing there. I'm going to put nothing. Zone 4 and zone 5, they're heating up here, so we'll look at zone 4. Thing I took out of this is carbonyl. So this with the carboxylic acid, I'm going to say that there's most likely a CO double bond in this molecule. And then as we move to zone 5, this will represent an aromatic. And we have this come up twice, so I'm going to say that it's highly likely that we'll see 1, if not 2 aromatics in the future part. As we move into proton NMR, I've pre-drawn the molecule here, so we could look at the hydrogens on it. So first off, I'm going to start with the least electronegative hydrogen, which is at a 7.6 here. There's only 1 on it. It's going to represent an aromatic. And actually the next 3 are in the aromatic region as well. So I'm going to write that down. And then I'm going to label them with letters so it's easier to see where these hydrogens are. This first one here is actually this one right here, farthest away from these 3 O's, which are, since they're so close together, it's going to be the most electronegative part of the atom. So I'm going to circle this hydrogen for you, labeled F. Next one is 7.8, E. It's going to be, actually I forgot to draw it in, actually. It's going to be right here. Circle that one for you, labeled it. It also accounts for 1 up here, up top. So I'll get to in a minute. Then the next one, D, is up by F over here because we're getting close, working our way closer to the electronegative part of the molecule. Labeled that at 8.2 counts for 1 hydrogen. And then the last one of the aromatic, 8.9. As we look at the C part here, so the last one of the aromatic, which you can see is right here. So I'll label that C, circle it for you. Also, it accounts for 1 up here, so I'll write that down. Next one is a little hump right here, but it still accounts for 1 at 13.4. It's actually in the alcohol region, but it's just outside of it, so I said it was shifted by the aromatic and also the carboxylic acid. So I'll label that B, circle the hydrogen up here, label it B up here too, and that accounts for 1 hydrogen, so I'll put it above this little bump. Then the last one right here, this is going to be the carboxylic acid part, or the hydrogen on the carboxylic acid. So I'll write that down, label it A, work our way from least electronegative to the most electronegative, did it in increasing alphabetical order. So I'll circle that hydrogen, label it A, put it down here. As you can see, there's 6 ones, and as we remember that there were 6 hydrogens in the molecule, as you can see here. So everything's worked out so far. As we wrap up with carbon-13 NMR here, we can remember that there are 10 carbons in the molecule, which we see represented by these 10 lines. I've put the numbers down here to make it easier. The aromatic region in the carbon-13 runs from 100 to 155 parts per million. So the last number in here is 145.8, so I'm going to write aromatic for all of these. Space it out, make it easier. I'm going to go in decreasing order of numbers from least electronegative to most electronegative. So I'll get those numbers down for you and then show you where they work out. So this first one here at 108.3 is going to represent by this 10 because it's bonded to 3 other carbons, which will make it the least electronegative. 9 comes in over here. It's bonded to 2 carbons, has 1 hydrogen off of it. Next one at 123.3 is the 8, which is down here. It's bonded to a nitrogen, which is less than the carbons, so that helps out. Then 2 other carbons. Then 7, it's farther away from the electronegative part. 6, somewhat close to this chlorine, which can be electronegative, but not as bad as this alcohol and carboxylic acid. So that's why the 5's on the chlorine. And then 4, working our way up there. It's right here. 3, getting pretty close. And then that wraps up for the aromatics. At 165.8, this is going to be an alcohol. Label it 2, and you can see up here in this corner, it's at the alcohol, and it's pretty close to the carboxylic acid, which comes in at 177.8. Label that with CA. And this is going to be 1 because it is attached to the most electronegative part of the atom, which you can see is right here.
And that wraps it up for spectroscopy. I'm Mason Coon. Thanks for watching.